Matrix inverses we're going to talk about today. Remember when you're way back when you were learning about solving equations for a single variable and you used inverse operations where in order to undo an add you had to subtract, and in order to undo a multiply you had to divide, and we had all these inverse operations? Well, we have the same thing when we deal with matrices where we've got inverse operations. Now, you might also remember that an inverse operation would end up giving you an identity. So for example, if I had 1 and I added it to its additive inverse, -1, I would end up getting 0, and 0 is actually what we call an identity element. Or if I had 2/3 and I multiplied it times 3/2, split the fraction, and you get its inverse, the inverse is the thing you would multiply together to get 1, because 1 was also one of those identity numbers. In order for us to understand about inverses, we have to also understand about identities. Okay, so instead of it just being a simple 1 or a simple 0 for an identity number in a matrix, you end up having the identity matrix being a square matrix that has 1s across the corners. Almost makes you think of echelon form, but it's also got 0s in the rest of the spots. So 1s down across from upper left to lower right. And even here, if it goes on and it had a bigger matrix, it'd be 1s down all the way across diagonally and 0s in the other places. So that's called an identity matrix, and it'll make sense hopefully soon as far as why we need an identity matrix. Okay. So the idea is just like in regular multiplication, if you multiply by the reciprocal, okay, you would end up getting an example, you would get an answer of 1. Or if you multiply by 1, you would end up getting the same number. That would be its identity. So A times the identity matrix gives you A back, or I times A gives you A, as long as A is square. Now, the very interesting thing about this is that this is, it does kind of run into this idea of being commutative. It's the only time we really talk about commutativity in matrices, but it has to be only when A is square. If A is not a square matrix, that identity idea doesn't work as far as being able to switch their orders. So we've got to be careful with that. So AI does equal A and IA equals A. It's kind of like multiplying by 1, but the 1s are all down the sides. So inverse, so A inverse, this little -1 up here does not mean 1 over the matrix A. It's the inverse of matrix A. It's what you can multiply times A to get the identity. So just like you could multiply by a reciprocal, if it was just a regular fraction and get the number 1, here you multiply the inverse matrix times the original matrix and it gets you an identity. And we're going to look at the processes now, since so many things can be done on the calculator. It's not as much as far as being an epiphany for everybody. It just works for some people as far as being super useful. But if your calculators all of a sudden stop working, people would still be able to use this almost as a cheat for the math to be able to solve things. Right now, just kind of hang in there because it's going to be a lot of stuff It's a long process to find an inverse matrix. And we are going to use the calculator just a bit because it's arduous and I don't want to completely ruin your lives. All right, here we go. So if we want to find an inverse, what we need to do is we start off by writing an augmented matrix. Now the augmented matrices that we used before was just for equations, but this augmented matrix has the starting matrix on the left. And on the right, we have, what's this look like we just talked about? What type of matrix? The identity, yeah. So the identity matrix on the right and the starting matrix on the left. And what we need to do is we need to go back to row operations. Everybody's loves because it's your favorite thing in life. We're going to go back to row operations and we're going to perform row operations until we get an identity on the left and other things on the right. And the thing that comes out on the right is going to end up being your inverse matrix. So we are going to take a look at these processes and go through them. And then some of them we'll revisit with the calculators because, like I said, it is kind of a long and arduous process that takes a really, really, really long time. So row operations. We're going to use the row operations to move the identity to the left. So in order to have an identity over here, we need to make this one into a 1. We need to make this one into a 0. We need to make this one into a 0, this one into a 1. So we have to go through a similar process that we did when we were trying to get into echelon form. So like the first thing here then, if we're trying to get a 1 up here, would be to do what to this row 1? Good. So multiply times -1/2 or divide by -2. And when we do row 1, divided by -2, turns this into a 1, this into a 5/2, this into a -1/2, and that into a 0. And we'll keep the other one just as it is for a minute. But we are trying to eventually turn something into a 0, and we're trying to just trying to get everything over here into the right form. Now, don't let this one fool you. He might have to go away for a little while. But I want to consider what happens if I do -3 times R1 plus R2. Does that look somewhat familiar to you as far as what we did before?
Yeah.
Multiply this times -3 and this add to this so we get a 0 down here. Because if we work on it to put it into echelon form first, okay, then after that we need to work on our last 0 up here. But let's work on echelon form first. So we've got -3 times this plus this gives us 0. -3 times 5/2 would give us 15/2 plus 1 would give us 17/2 because it's 2/2. Because -3 times -5 would give you 15/2. 15/2 plus 2/2 gives you 17/2. -3 times 1/2 would give us 3/2. Plus 0 would give you 3/2. -3 times 0 gives 0, plus 1 gives 1. So far, so good. We almost have a couple things taken care of. What do you suppose next? Positive 2/17. So positive 2/17. And then when we do times 2/17, makes this into a 1. And yes, I've got a whole bunch of other stuff that we're going to just cover up here right now. So when you do times 2/17, it does get rid of this, turns this one into There might be a mistake with that. No, 2 over 17, because it cancels out the 2's. We get 3 over 17. And then 2 over 17 here. And then what's the one last thing that we need to get rid of to put it into that so that the identity matrix, negative 5 over 2. So what do you, actually, what gets multiplied by, we can't multiply it by 0 because that'll cancel everything out. Your 2 over 5 is not a bad idea, but it's not going to be multiplied this. And actually, negative 2 over 5 is, which one will we multiply by positive 2 over 5? If we multiply this one by positive 2 over 5, we end up with 2 over 5 here. And we end up with negative 1 here. So that's not going to do it. But 2 over 5 definitely is what we have to do to something. What can we multiply the bottom row by 2 over 5 and then do what with it? Because we're trying to get 0 here. Add it to this one. So we're going kind of backwards up to get this guy. So we do our echelon form process first and then do the other thing to pull up to take care of this one above it. So times negative 2 over 5 on the second row, or 5 over 2. 5 over 2, not 2 over 5, because we have to add it then to the top row. 2 over 5 would work if we multiplied, so we needed to, but we're going to be adding this. So 5 over 2 times 1 gives you 5 over 2, plus negative 5 over 2 gives us 0. So we're to the point where we've got our 0 there. So when we do 5 over 2 times 1/2, or 5 over 2 times 3 over 17, 5 over 2 times 3 over 17, and then we add it to negative 1/2, it takes a little bit more of a process to get this. We are going to end up with negative 1/17, and then the other one turns out to be 5/17 when we take 5 over 2 times 0. 5 over 2 times 2/17. You get 5/17 plus 0. Hold on. I think this one's messed up, isn't it? Let's do this one on the side, because we're doing 5/2 times row 2. 5/2 times row 2 times 2/17 gives us 5 over 17. And 5 over 17 plus plus 0 gives us 5/17. This should be a 5. So we'll fix that one. I'm just going to cover that over. Let's just change it like this because it's hard to write here. This one should be 5/17. It's not writing for me. 5/17. Sorry, this part writes better. So I'm going to copy it and put it over here. Paste it over here. There we go. I know that's the strangest thing, but it just writes better when I put it on the paint. So 5/17, and then this one would be, did I mess this one up too? I think so. But this is actually very good because we're taking 5 over 2 times row 1 times row 2, 3/17. And that equals 15/34. Yeah, that one's messed up too. So 1530 seconds would be in, oh no, it's in row 1. It's not in row 2. Hold up. Hold up. I need to do some editing. I need to do some on the board. Hold on. Wrong. Recorder, where are you? Okay, so once again, this is all fine. We took our 5/2 times row 2 plus row 1 and replaced it, put it in here. So 5/2 times -1 is 5/2 plus -5/2 gives us 0. 5/2 times 3/17 gives us 15/34 plus -1/2 gives us -1/17 once we reduce it. 5/2 times 2/17 gives us 5/17 plus 0 gives us 5/17, which goes here. So once you've done that and you've moved all of the ones and zeros over to the left, your inverse matrix equals -1/17, 5/17, 3/17, and 2/17. It equals what shows up on the right-hand side of the augmented matrix. Yeah. So it moved over, it's the inverse. So if I were to multiply this times this, our original matrix, you would get the identity matrix 1, 1, 0, 0. Yes. All right, so let's just kind of move on with that. Okay, now I want to show you this, but I also want to show you I want to show you a shortcut. I want to show you what to do with your calculator on this. So just kind of follow along a little bit, but don't necessarily write it all down. Because as you can see that this is a very, very long process. And we want to be able to use your technology so you don't have to go through all this. Because what we could do is we could do all of this, okay? To find an inverse matrix, we could do all of this. So we could put it in, like I say, don't take the time necessarily to write it down. We could put in our identity matrix here, and then we could go through the process for echelon form. I've got a couple steps at a time here. Don't write it down. Just pay attention for a minute. So I could go through multiplying -2 times R1 so that I could eliminate this and make it into a 0. I could go through multiplying -3 times R1 to add to this one to make this one a 0. Very nicely, because of the way it's arranged, it took a couple steps, so we're almost down to echelon form anyway. And then we could divide this one by -2, divide this one by -3 to get our ones down the corner. Okay. Or you can use other row operations. Okay. Like, for example, when you multiply times 1, you're really just trying to get things to turn into zeros and then trying to get it so that you end up with a 1 down there. So even if we didn't take our time on this and we did a whole bunch of steps all at once, you can see that you could do row operations to get your inverse, but let's take your calculator out and I'll show you how to find an inverse without having to show all those steps. All right. So what we would need to do is we would need to enter a matrix into the system. So on here, there is a matrix button. Help me find it. It's inverse X. So we want to go into matrix. And we want then to edit your matrix. So we want to put in matrix A. Our matrix A is a what by what matrix? 3 by 3. The original, not the augmented one, the 3 by 3. And we want to put our 3 by 3 matrix in here. So we're going to put in our 1. You can use the arrow keys to make this happen, or you can use the enter and then the arrow keys if we need to, and put in all of the numbers. You do have to hit enter to make it go in. So we'll just put in our numbers that we need. Don't forget to use little gray negative for your 2 or it will mess you up, not that blue one. We get all of our numbers in 3. All right, so we have all that. And if we want to actually see our matrix, everyone have that in? We want to actually see what our inverse is. We'll go to the main screen. If you wanted to see what it looked like, you could go to the matrix one again, second matrix, and you could just hit enter and hit enter, and you actually see the matrix. So this is what a matrix looks like. They put these double bracket things on there, but that's what it looks like. 1 0 1 2 -2 -1 3 0 0. But if we want the inverse, we could choose that same matrix, and then instead of hitting enter right away, notice how the inverse button is right here with the little -1 underneath the matrix button. And then we hit enter, and it gives us these numbers, okay? It's not showing up as a fraction, but if you have regular numbers and you want to make them into a fraction, who remembers how? How? Math, fraction. But you can do that with a matrix also and hit enter, and it turns it into the fraction form. And you can then see your different matrices. Now, if you'll notice, and if you notice, if you have these things over the other end, you need to actually use your arrow key to be able to see the rest of the fraction. But it's all in there as these matrices. Let me turn this off.